In this problem, we are going to sketch the graph of y equals sine of x plus pi over 2 for the range of the x between negative pi over 2 and 3 pi over 2. Consider the pattern y equals k plus a times sine of bx plus c. We can see that nothing added to the sine function, so that means our k is 0. Means 0 plus 1 times sine of 1x plus pi over 2. And then we're going to make a list on the side here. Since the a value is 1, the b value is 1, and the c value is pi over 2, the k value is 0. The value a tells you about the amplitude, which is the absolute value of the a, or 1. And this case, a is greater than 0. That means no reflection about the x-axis. The b value is used to compute the period. The period is 2 pi divided by b, or 2 pi divided by 1, or just 2 pi. And the value of the 2 pi is used to compute the width of the four equal subintervals. So it's going to be 2 pi divided by 4, which is the period, divided by 4, equals pi over 2. The value c is used to compute with the value b for the phase shift. The formula is negative c divided by b. The value c is negative pi over 2 divided by b, which is 1, and just turns out to be just negative pi over 2. And negative pi over 2 here will tell you the beginning of the cycle, or the beginning of the 5 key points that we're going to use it to complete one cycle. If it starts at the phase shift, so I'm going to put a note here, the graph start here. Start at negative pi over 2. So the next point going to be the negative pi over 2 plus pi over 2, or just the point 0. And then the next going to be the point pi over 2, and then pi, and then 3 pi over 2. So we get 5 positions for one complete cycle. And we're going to use these 5 points for the value of the x on the table. Negative pi over 2, use different color. So negative pi over 2, 0, pi over 2, pi, and then 3 pi over 2. Let's make the table bigger. Negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. The value of the sine for the 5 key points on the unit circle, the sine is the y coordinate. So starting at 0, and then 1, 0, negative 1, and then back to 0. So then the value that we're going to put in here on the table going to be starting 0, 1, 0, negative 1, and 0. Then we complete the table by making a list of the order pair that we're going to use in the graphing area. Negative pi over 2, comma 0, 0, comma 1, pi over 2, comma 0, pi, comma negative 1, and 3 pi over 2, comma 0. And we can see that the maximum value equals 1, minimum value is negative 1. As we can think about the list of the k here, since k is 0, so that means no vertical shift. So then the range of the graph is k plus the absolute value of the a, in case 0, so going to be just -1 to 1, which matching with the list of the max and min that we got from the table. Now, on the graphing area, the increment, the width is pi over 2, and then at the beginning point is -pi over 2. So we're going to start at the point -pi over 2 here, and go by pi over 2 at a time. The next point is 0. And then, how about we do this way? We make it in a bigger increment. So if this 0, this one is -pi over 2, and then add another pi over 2, add another pi over 2, and then the last point going to be 3 pi over 2. So we have the bigger graph here. The maximum is 1. The minimum is -1. Locate the order pair on the graph. At the point -pi over 2, the value is 0. The point 0, the function is 1. At pi over 2, the function value is 0. At pi, the function value is -1. At 3 pi over 2, the function value is 0. And then we're going to connect all the points with the smooth curve. The shape of the graph remains the same, but the graph is shifted to the left by pi over 2 units, which is the phase shift position. As you see the better looking graph, comparing with the original graph of the y equals psi of x in the blue graph here that I highlighted with the yellow color is shifted to the left by pi over 2, or with the value of the phase shift -pi over 2.